right, if you're listening to this lesson, then there must have been some snow, at least if you're my students, that is. And so hopefully you're enjoying your time. And this should be a quick lesson and something that hopefully does not give you much trouble. But I will tell you this, with work problems, this is something that almost every time you take the SAT, the Scholastic Aptitude Test for College, or the ACT, the American College Test, there's almost always at least one of these problems on that test. So if you know how to work the problem, so much easier. If not, you'd have to play around with the answers to try to see if you could figure out what it is. But knowing how to work the problems is way better, and so that's what we want to work on today. And so work problems. Work problems. All right. So what are you looking to do? Well, you're looking to organize the data with a chart. With a chart. All right. Jersey for a chart. And I put it in quotes because it's kind of a pseudo chart. I mean, this isn't a chart like some of the other charts we've done for interest problems and, rate times time, distance problems, stuff like that. But it's kind of a pseudo chart, and you'll see what I mean in a moment. But the key to the whole thing is the next statement. Note, the equation is the sum. All right, so then we're adding. And by the way, if you need to pause the video so you can write some of these things, go ahead and do that. I know you don't have a copy of these notes due to the late minute situation with the video. So the equation is the sum of the reciprocals of the individual times. The sum of the reciprocals of the individual times equals, so that's your equal sign, the reciprocal of the time together. The reciprocal of the time together. So these are all going to involve times in some aspect. How long does it take a 3-inch pipe to fill a tank? Those kinds of things. All right. So let's take a look at an example. And again, I would recommend that you pause the video so you can write the example problem, because I'm going to just get right on with it. All right. So you might want to pause, write it down so you have it in your notes. All right. Tim can paint a room in 8 hours. Lou can paint the same room in 6 hours. If they paint together, how long will it take? All right, so the chart is just real easy. It's the people, it's the time, and I usually like to put the units here to keep track. And I'm going to put hours. And then the last column coming from that is the reciprocals. The reciprocals. Okay, not a big deal. All right, so I'm orderly, so I'm going to go in order. The first person we talk about is Tim, so I'm going to put Tim. And Tim's time is 8 hours. All right, easy enough. Tim and 8 hours. Go to the next one. We got Lou, right? Lou can paint the same room in 6 hours. So we got Lou, and we got 6 hours. And finally, you got the aspect of the together. And you always have it together. And in this case, together is the variable. So a lot of times when we were filling out charts, we would always do the variable first. And you could do that. If you would first write Tim, Lou, and together, then you could actually fill in the variable before you fill in anybody else's times. But times are pretty easy. It tells you, hey, Tim painted 8 hours. That's obvious, and so you don't need to do that. It's not necessary. It doesn't really help you that much. Okay, reciprocals. Every reciprocal is a 1 over. And so you just take and do 1 over. 1 over Tim's time, 1 over 8. Lou, 1 over Lou's time, 1 over 6. And together, 1 over the together time, 1 over x. And so the sum of those reciprocals equals the reciprocal of the together time. So your equation is really right here. Okay? So let's move out. We're going to write our equation. Now I'm going to leave some space because I'm going to work right off the original equation. So I'm going to write 1/8, and I'm going to give myself some space, and I'm going to put that plus sign. And then I'm going to do 1/6, and I'm going to give myself some space before I do the equal sign. And then finally, what the together is, 1 over x. So our equation is 1/8 plus 1/6 equals 1 over x. And hopefully by now you're beginning to see why these problems are tucked into Chapter 9. We've been working through radical equations, And that's exactly what we have, right? We have a radical equation. We have an equation with the variable. Oh, I'm sorry, rational equation, radical, brother, rational equation. So we've got an equation with fractions, and the variable is the denominator of a fraction. So if you remember the next step, we want to multiply by the LCD to be able to get rid of all the fractions. But remember, we have to multiply each term by that LCD. So you got to look, you've got an 8, a 6, and an x. So again, if you understand LCDs, you can figure this out in your head. If you don't understand LCDs, then it might take you a little bit more work. And sometimes you'll find a common denominator, not just the lowest common denominator. The LCD is the best, the lowest one. But it will work if it's something common. So really, it's 24x is the LCD. From the 8 and the 6, the common then is a 24, and then the x. So we're going to multiply the front term by 24x. We're going to multiply the second term by 24x. And we're going to multiply the right-hand side by 24x. Okay? Again, this methodology is the way of ridding equations of fractions, and that's what we want to do. So as we continue, the 8 should divide into the 24. If not, you made a mistake, and we're left with 3x. The 6 should divide into the 24. If not, you made a mistake, and that leaves you a 4. And of course, the x's divide out here. So where are we at? We now have 3x plus 4x equals 24, and we're just about done. We are just about done. So 7x equals 24, and we know to divide both sides by the 7. And we end up with x equals 24 sevenths. And what did we find? What is x? Look at your pseudo chart. X is hours, so this is hours. You ever hear anybody talk like, yeah, I worked 24 sevenths hours last week? No, we don't talk that way, right? So let's go ahead and convert this to a mixed number. So what is that? 3 and 3/7 hours. That sounds more plausible of an answer, right? 3 and 3/7 hours. Now, by the way, with word problems, it's always important to ask the ma'ams, does my answer make sense? Go back and look at the problem. Hey, Tim paints the room in 8 hours, right? Lou paints it in 6. If there were 2 Lou's, you'd be done in 3 hours. If there were 2 Tims, you'd be done in 4 hours. So there's 1 Tim, 1 Lou. We got to be somewhere between 4 and 3 hours. And sure enough, our answer is between 4 and 3 hours. So let me recap for you. Real simple. List out the people and then list out the together at the bottom. Fill in their times. Now the variable in this case was together. It may not be together. I'll show you in the next problem. But you always have a column for the reciprocals, 1 over each time. And the equation is always all the people's time always equals the together. Okay? It always equals the together. Now the rest is just problem solving. The rest is just problem solving. Okay? That's what we're doing. I got one more example, and that's going to be it for today. All right, so let's take a look at number 3. Again, pause the video if you need time to write down the question, and I'm sure you do. Tina can type a report in 40 minutes. If it takes Sue, an hour to type the same report. If Rose helps, all 3 can finish it in 15 minutes. How long would it take Rosa? Oh, that's good. I went from Rose to Rosa. Sorry about that. First edition situation. How long would it take Rose to type it by herself? Okay? So that's the situation. So we need our pseudo chart. So again, you got the workers, the people, whatever you want to title that, right? You got the time. Oh, excuse me. Sorry about that. You got the time. And I'm going to hold off on the minutes for a second, okay? And then finally, you have the reciprocals. I'm just going to do recip. Okay, let's list off the workers first. I have Tina. I have Sue. I have Rose, not Rosa. although that sounds like a good Italian girl. All right, Tina, Sue, Rose, and then lastly, there's always together. Together. Okay, so before I tell you the time, and this is a key one here, I'm going to use my red. You got to look at what you've got. All right, so let's look at Tina. Tina's 40 minutes. Sue is an hour. Rose helping 15 minutes. We have minutes, minutes, and hour. Is it easier to put an hour into minutes or minutes into an hour? And hopefully you say it's so much easier to put an hour into minutes. Yeah, it is. And the units have to match, so I'm going to go minutes. Now that's important. If you don't do that, you're going to mess up the problem. All right, you are going to mess up the problem. All right, I'm going to use my blue. So now I'm ready to go through and write in the time. So Tina, 40 minutes. Sue, an hour. Now, be careful. This is where some will make a mistake just because they don't carefully read the problem. If Rose helps all three, that's the together. And the together is 15 minutes. Now, again, you can avoid that by using the methodology that I taught you on some of the other problems and answering the question, how long would it take Rose to type it by herself? So the X is Rose. Okay? So we got 40, 60, X, and 15. So our recips are easy. 1 over, 1 over, 1 over, 1 over. So we got 1 over 40, 1 over 60, 1 over X, and 1 over 15. Now remember, your equation is going to come from your recip column. And remember, everybody's work equals the together. So let's go ahead and write our equation. 1/40th. Again, I'm going to leave some space to do my multiplying. Plus 1/60th. Again, I'm going to leave some space to do my multiplying. Plus 1 over X. Leave some space for my multiplying. Equals 1 over 15. Okay, the toughest part for a problem like this might be for you to find the LCD. So you can go all the way back to the pre-algebra situation and write a chart to figure out the LCD. And again, you can use a non-common denominator. You'll still end up in the right place, but you have to find numbers that everything divides into. Okay? So a 40 and a 60 and a 15 and an X. You got to figure out, hey, what is this LCD? Well, the LCD is, if you don't want me to tell you, pause it right now and you can figure it out on your own. The LCD is 120x. This number, all four denominators must be able to divide into this number. And they do. 40 divides into it, 60 divides into it, X divides into it, and 15 divides into it. And if not, then it doesn't work. Okay? All four denominators have to divide into it. Again, you could have used another non-lowest common denominator, but that's the best. Okay, 120x times the first, 120x times the second, 120x times the third, and don't forget the other side also gets the 120x. So I'm going to use my red here to illustrate the division. So if you did everything right, you can divide the 120 by the 40. And what do you get? You get 3, right? You can divide the 120 by the 60, not the x there, right? Just the 120, and you get 2. And the third, divide out your x's, you still have the 120. And on the fourth, you're going to divide the 120 by the 15, and 15 goes into 120 8 times. Okay? Let's write now where we're at. Front term, 3x, plus second term, 2x, plus third term, 120, equals last term, 8x. All right, piece of cake. Now I can decide to move all my variables to the left or move all my variables to the right, right? You look at this and your assessment is, hey, I have an equation with variables on both sides. So what do I want to do? I want to choose a side and get all variables on the one side. So you can choose the left side or choose the right. I always choose the side that has the variable end up being positive. So I want to move the 3x and the 2x to the opposite side. 3x and 2x is 5x, so let's add a negative 5x to both sides. So now we're at 120 equals 3x. And how do we move that 3? We'll divide both sides by the 3. And we end up with x equals 40. And what are our units? Minutes. And how long does it take Rose to type it? Hey, Rose does it in 40 minutes just like Tina did it in 40 minutes. And Sue, it takes an hour. So again, think, does my answer make sense? Go back to the original problem. Hey, if there were 3 Tinas and Tina can do it in 40 minutes, 3 of them would be then, 2 of them would be 20 minutes, and a third one would be 10 minutes if there were 3 Tinas. So again, it depends on the situation. Now you got Sue who takes a little longer. A second Sue would be a half an hour, and then half of that, etc. You got to figure it out. Okay, it gives you a ballpark idea. So Rose, 40 minutes, yeah, that makes sense to me. I like my answer. Hey, that's what these are, and that's all these are. And again, it could be a water pipe filling up a tank. It could be how long Sally takes to fill up the bathtub. If, this and that. It could be how long the computer takes to compute um, some kind of logarithm, whatever. All right, all kinds of different situations, but time's going to be involved. The equation's always the recips, so you always have to multiply through to get rid of the fractions, and away you go. Okay? You can do it. I know you can. Go back and look at the video again if you need to, but that's the idea. So here's your work. This is page 386, and it's 9, 13, a couple odds. Come back then and get 12 and 14, a couple evens, and finish off with some review, 21 to 24. Okay? And that'll be due the next time class meets. So next time I see you in class, not only should you have watched this video, but you should have that homework prepared and ready to go. All right? Hope you enjoy your time at home. Bye.